The paper is Main Memory Database Systems and Overview. It's a 1992 paper. Main memory database systems, aka MMDBs, store their data in main physical memory and provide high-speed access. Conventional database systems are optimized for the particular characteristics of disk storage mechanisms. Memory resident systems, on the other hand, use different optimizations to structure and organize data, as well as to make it reliable. The authors survey the major memory residence optimizations and briefly discuss some of the MMDBs that have been designed or implemented. A computer's main memory clearly has different properties from that of magnetic disks, and these differences have profound implications on the design and performance of the database systems. The paper has outlined some of the key characteristics. First, the access time for main memory is orders of magnitude less than for disk storage. Main memory is normally volatile while disk storage is not. However, it's possible at some cost to construct non-volatile main memory. Disks have a high fixed cost per access that does not depend on the amount of data that is retrieved during the access. For this reason, disks are block-oriented storage devices, while main memory is not block-oriented. The layout of data on disk is much more critical than the layout of data in main memory, since sequential access to a disk is faster than random access. Sequential access is not as important in main memories. Main memory is normally directly accessible by the processor while disks are not. This may make data in main memory more vulnerable than disk resident data to software errors. Now coming to contributions of the paper. The paper surveys the impact of memory residency on some of the functional components of database management systems like concurrency control, commit processing, access methods, data representation, query processing, recovery, and performance. The paper surveys few memory resident data systems ranging from pencil and paper designs like MMDBMS, MARS, Halo, to prototype or testbed implementations like OBE, TPK, and System M. Now let's give this paper a PS score. It's a nice read of memory resident DBMS, so on readability it gets 8 out of 10. It's a relatively crisp paper with 8 pages long, so on length it gets 9 out of 10. This being a 1992 paper, reproducibility might be a challenge, so it gets 8 out of 10. Overall good lessons and overview for industry and database enthusiasts, so it gets 8 out of 10 in industry value and on learning meter category. So the overall PS score is 8 out of 10.